Hello students and welcome to your new unit. Today we're going to start introducing a new chapter where we're going to be talking about lots of different topics, and soon to come will be your bell work, so please pay close attention to this video so that you can best get an understanding of the chapter. So first we're going to start off by including a couple of definitions. So an experiment is a planned operation under controlled conditions with certain outcomes. So controlled experiments consist of for example, coin flip, where you know that the options could be heads or tails. Those are certain outcomes. Or the rolling of a dice, where you know the outcomes when you roll a fair dice one time could be 1, 2, 3, 4, 5, or 6. The sample space is the description of all of the outcomes that can possibly occur. So what are all of the possible outcomes? And this sample space is actually going to be denoted by a specific notation. So when you have a sample space S is equal to, then you have these swirly brackets right here. So this defines our sample space right here. Boom. So events are each outcome and they go within the sample space. So we would have outcome 1, outcome 2, and so on and so forth. So when we think of our example and we're flipping our money coin, our sample space would be equal to what? Well, we have heads and we have tails. So that would be your sample space if you flipped a coin. So for your bell work today, I'm going to give you a question here. All right, your bell work is to write the sample space of a single dice roll. So what would be your sample space? Make sure that you use these brackets of a dice roll. All right, go ahead and pause your screen to complete your bell work and make sure that you put it within your bell work quiz. All right, next we're going to be talking about probability. Probability is denoted with a P. And probability is defined as the likelihood of an event occurring. So if we're flipping a coin, the probability would be of our coin flip. So what would be the probability of a certain event, the event would go within there, happening? So let's talk about this. So we have the probability of the event of heads, and we also have the probability of the event tails with one single coin flip. And these are actually equal in this instance because when you flip a coin on a fair dice, you have an equal chance of getting heads and an equal chance of getting tails. Probability is always, of any event, is always greater than or equal to 0 and less than or equal to 1. Where 1 would mean 100% of the time this event is happening, and 0 would mean 0% of the time this event is happening. So if we go back to our example here of the probability of heads is equal to the probability of tails, well, if we know the entire probability of all outcomes is equal to 1, well, then you know the probability of heads is 50% or 0.5, and the probability of tails is equal to also 0.5. This would mean that there's a 50% of getting heads and a 50% of getting tails. Now, if we go back to our example that we talked about, our dice, Well, on a dice, we have 6 different possible outcomes. That's our sample space. So the probability of getting a 1 is part of the probability of getting, or of rolling a 2 is part of the probability of rolling a 3, and then a 4, and then, and then a 5, and then a 6. And all of these probabilities together are going to give us 1. So the probability of all the outcomes together has to give you 1. Well, if all of these have an equal chance of occurring, the probability of getting a 1 is equal to 1 out of the total number of possible outcomes. We have 1 outcome, 2 outcomes, 3 outcomes, 4 outcomes, 5 outcomes, 6 outcomes. So the probability of getting a 1 is 1 out of 6. And this would be true for the probability of each of these. The probability of 2 would also be 1 out of 6 because you have a 1 out of 1, 2, 3, 4, 5, 6. You have a 1 out of 6 shot of rolling a 2 on your fair dice. Okay, your exit ticket today is to think about the following. Okay, so you are trying to find what does it mean to have a probability of 0? What does it mean to have a probability of 0? What does this mean? Go ahead and pause your screen, take a couple of minutes to think about this, and record your answer for your exit ticket. But don't worry, there is still more lecture to come, so please do not leave this video yet. Okay, now we're going to do an example problem where we kind of talk about outcomes, samples, and basically how to think of these things. So we are looking to find the event T occurring when we roll a dice. So what is our sample space? Our sample space on a dice is always going to be 1 through 6, right? But for this one, our outcome is a 2. So our sample space is 1, 2, 3, 4, 5, and 6. And we're looking for the probability of T happening, which we say event T is the outcome of a 2, which is equal to just 2, right? That's the only thing in our sample space for T. So T is going to be, we don't actually worry about probability yet. We're looking for the sample space of T is 2. All right, for event A, let me fix that. Okay, so for event A, we're going to make this pink really quick. We've got the event A. We'll just pretend it's pink. And the outcome is an even number. So what is our sample space for A? Well, we have which ones on the dice are even. That would be 2, 4, and 6. So this is our sample space for the event A. And finally, for our sample space for event B, we want to have an outcome less than 4. Well, we don't include 4 because it doesn't say less than or equal to, it just says less than 4. So we're going to have 1, 2, and 3. So now we're going to backtrack for a second, and we're going to talk about what does it mean to have a prime or basically a symbol that means prime. Okay, so we're going to talk about the prime point of each of these samples. So we are going to erase the probability here too. Okay, so here were our sample spaces for each of the following. Remember that T was equal to the probability of rolling a 2, A was equal to the sample space for rolling a even number, and B was the sample space for rolling a number that was less than 3. So now we're going to talk about primes, which is denoted by this symbol right here, T prime. So T prime is equal to the sample space that includes everything but T. So if we're rolling a dice, we would have 1, 2, but since 2 is included in T, we do not include it in T prime. 3, 4, 5, and 6. Okay, now for A prime. What would we have for A prime? Well, for A prime, we include everything that is not within A. So if we're rolling a dice, we would have 1, 2 is in A, so it's not in A prime. 3, 4, which is in A, so it's not going in A prime. 5, and 6, but 6 is in A, so it doesn't go in A prime. All right, and finally, let's go over B prime. Where we don't include the numbers that were in B. So we will have B prime sample space is equal to 4, 5, and 6. So hopefully that makes a little bit more sense about what the prime means. It is all possible to where the entire sample will be within our 2 primes our first sample space and our prime sample space. I wanted to note that each of these prime along with the unprimed letters create the complement sample spaces, where the sample space of anything has to be within P or P prime. These are complements of each other. All right, now that we've gone over a lot of the terminology, let's do some practice. So when we started with our sample of our T, which it was for rolling a number 2 on a dice, our sample space was 2. Well, then our complement was 1, 3, 4, 5, and 6. So our probability of rolling a 2 is equal to the sample space of that, which is how many? How many is in there? There is 1 number in there out of the sample space of both the complement pieces, which would be 1, 2, 3, 4, 5, 6. And those are 6 outcomes. So this is how many are in your sample space, not the number 2, plus all of the possible outcomes, which is here. So the probability of rolling a 2 on a dice is 1 out of 6. Let's go back to our other example, which wanted to calculate the probability of getting an even number on our dice. So just to keep our colors coordinated. Here's our pink. So we had A sample space was 2, 4, and 6, where those are the even numbers that are on the dice. And we know that a dice has 6 sides. So A prime, if we were going to review this again, which is its complement, would be 1, 3, and 5, which are the other numbers on the dice that aren't listed in the original sample space. So the probability of A occurring, and we have 1, 2, 3 events that make A happen, would be 3 out of 1, 2, 3, 4, 5, 6. 3 out of 6. And if you simplify that, you get 1/2, which is equal to 0.5. So the probability of A is 50% or 0.5 in a decimal form. And finally, let's do the probability of having a number less than 4. So for our probability of having a number less than 4, this was denoted by B, and the sample space was 1, 2, and 3. Oops, I forgot one. 1, 2, and 3. So the probability of B happening would be equal to the number of outcomes in our sample space, which is 3, over the total number of outcomes in our sample space, which would be 6, because we have a 6 numbered dice rather. We can simplify that down to 1/2, and then we can simplify that to 0.5.